All right, we're going to pick up today's lesson talking about the greatest common factor, least common multiple, equivalent fractions, and simplest form. We are going to do all of that using the upside down division, the UD. So you're going to hear us talk about UD, upside down division. Some call it ladder, but it will be upside down division. So if you take as you take those notes, I'll give you just a second. And then we're going to move in to finding the greatest common factor first. So once again, we're going to find the greatest common factor, which is your GCF, your LCM, which is your least common multiple, equivalent fractions, equivalent means equal, and simplest form. That means taking a fraction and reducing it down to its lowest form. And we will do that using our upside down division. So now, with that said, we will start off on the first one. Let's say we had the numbers 24 and 36, and I wanted to find the greatest common factor. Probably previously you have been taught to list all the factors of 24 and then all the factors of 36 and find the one that's the greatest common factor. Well, this time we're going to use upside down division. So if we say upside down division, it's doing an upside down division house. Now I am going to find a number that is divisible by both of these that I can think of. Now we learned our divisibility rules yesterday. So when I think of greatest common factor, I'm thinking of the factor that both of them are divisible by. So I know, if I'm not sure offhand, that they're both divisible by 2 because they both end with an even number. Well, I can think of maybe 4. 4 can both go into them. Well, I'm just going to pick one just in case you're not sure. So I'm going to go with 2 just to begin with. Let's say I didn't know anything else except 2. Well, I can go with that. Now, what are we going to do? We're going to divide out. That's what upside down division means. So 24 divided by 2 is 12. Put my comma. 36 divided by 2 is 18. Well, both of these are still even numbers, so I'm going to pull out a 2. 12 divided by 2 is 6. 18 divided by 2, oops, let me back that up, back, 2. 12 divided by 2 is 6, and 18 divided by 2 is 9. Well, now if I look at both of those, they are both divisible by not 2 because that's an even number, but 3 will go in there. So I'm going to do another one, pull out 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now, 2 and 3 doesn't have anything else in common except 1. So that means I'm done. So I've got to find my greatest common factor. Now, the greatest common factor is just like drawing a big G here. It's going to be the product. Product means multiplication of what I pulled out. I pulled out 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. So the greatest common factor of 24 and 36 is 12. Now let's do another one. Make sure we have all that before I erase it. Now the next one I want to do is, let's say, maybe 16 and 24. I want to pull out the greatest common factor. Well, now looking at both of those, I know that 4 will go into them. So I'm going to start with 4 this time instead of 2. And like I said, you can go big if you know. 16 divided by 4 is 4. 24 divided by 4 is 6. Now, is there anything else that can come out of there? Yes, they're both even, so 2 will. 4 divided by 2 is 2. 6 divided by 2 is 3. Nothing else in common. So what is my greatest common factor? 4 times 2, which is 8. So the greatest common factor is 8. Now, if I would have pulled out 8 from the beginning, because I knew that 8 went into both 16 and 24, I would have had it right off from the get-go. And that's okay if you do something like that. All right, let's do one more. Let's say you had 35 and 60. Well, now as I look at both of those numbers, I know they're not divisible by 2. This is not going to be divisible by any even number. But when I look right off, I notice they both end with 5 and 0, which means they are divisible by 5. Divide them out. 35 divided by 5 is 7. 60 divided by 5 is 12. 7 and 12 have nothing else in common, so that means I'm done. So the greatest common factor is what I pulled out. Only 5, so that's going to be my greatest common factor is going to be 5. And a lot of times that will happen. You may pull it out on the first try. So finding greatest common factor, we are going to pull out till we get nothing left where they have nothing else in common. Now, this same method works for least common multiple. So let's say I had the numbers 24 and 36. I'm going to go back to those two. Remember, pulling out greatest common factor, we pulled out. Well, if I look at those, remember I knew that 12 came out, but let's say I didn't. Let's say I went with 6. 24 divided by 6 is 4. 36 divided by 6 is 6. Still have something in common. Pull out a 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Now, remember my greatest common factor, we already found that out already. Greatest common factor was 6. Now, I'm going to actually just erase this big G that I put here. Now, the least common multiple is done on the outside. It makes a big L. And there is my least common multiple. So now I'm just going to multiply all of those. 6 times 2 we knew is 12. 2 times 3 is 6. So 12 times 6 is 72. So my least common multiple is 72. So everything's from the outside. So you get the big L is your least common multiple and the G is your greatest common factor. Now you're going to be surprised at those two numbers that I just gave you, that 24 and 36, that not only finding the greatest common factor, which we just pulled out, we knew was 12, which left us with 2 and 3, and we got the least common multiple, you had the greatest common factor, which was 12. Remember, the least common multiple was, pulling them out, was 12 times 6, which was 72. Well, if this was a fraction that was actually 24 over 36, and I wanted you to reduce it to simplest form, well, guess what? Your simplest form would be with what? Your leftover, which is 2/3. It would also be considered an equivalent fraction. So now let that sink in a second. From one here, one upside down division, I can find out the greatest common factor, the least common multiple, an equivalent fraction, and simplest form. So let's do that on a couple others. Let's say my number was 18 and let's say 42. Now, I want to find my greatest common factor. I want to know my least common multiple. I'm going to find an equivalent fraction, and I'm going to reduce it to simplest form. Now, let me grab my camera. It's about to fall on me. All right, so with that said, I'm going to pull out. Now, if I'm unsure what to pull out, I'm going to go small, especially if I want equivalent fractions. So I'm going to pull out a 2 because they're both even. 18 divided by 2 is 9. 42 divided by 2 is 21. Now, I see that both 9 and 21 are multiples of 3. 3 is divisible. 9 divided by 3 is 3. 21 divided by 3 is 7. Now, 3 and 7 have nothing else in common except 1. So my greatest common factor is what I actually pulled out up here, the product. 2 times 3, which is 6. The least common multiple is everything outside. Remember the big L. So 6 times 3 times 7 is 21. So if I wanted to multiply, if I was unsure how to do that, I can remember multiply 6 under there would be a 6, it'd be 12, so 126 would be my least common multiple. Equivalent fraction. Well, if this fraction was here, 18 over 42, what would be an equivalent fraction? The next one in line, 921. What's also an equivalent fraction? Well, the 3/7. So both of these are equivalent fractions. Now, which one is my simplest form? That means bringing it down to its simplest form, to where the lowest I can get it. That is this right here. So the simplest form would be 3/7. So as you're finished writing that down, I'm going to adjust my camera just a minute, because it's wanting to slide a little bit. All right, let's start the next one. All right, now let's say I wanted to find out all of the same things, and I'm going to use the numbers 25 and 75. So let's say this was a fraction of 25 over 75. I wanted to find the greatest common factor. I want to know the least common multiple. I want to know an equivalent fraction. And I want to know one that will be the simplest form. Remember, there's only going to be one simplest form, but I might get several equivalent. Now, if I look at both of these, I'm thinking they both end with 5, so I know it's divisible by 5. 25 divided by 5 is 5. 75 divided by 5 is 15. Now, do those both still have something in common? Yes, they both have a 5. But if I look, right there's one of my equivalent fractions, 5 over 15. Now the next one, if I go to pull out a 5, 5 divided by 5 is 1, 15 divided by 5 is 3. Those have nothing else in common, so I'm done. Now I know that's going to be my simplest form. It's also an equivalent fraction. But now my greatest common factor, the product of what I pulled out 5 times up here, 5 times 5, which is 25. And my least common multiple is going to be that 25 times 3, which is 75. So there's finding my greatest common factor, my least common multiple, equivalent fraction, and simplest form. Now I'm going to finish up with one last thing, because I want to show you, can you pull out a greatest common factor and least common multiple out of if you had 3 terms? So let's try that out. Let me adjust my camera again. This pole is not working that well for me. All right, let's say I had 24, 36, and 60. If I wanted to find the greatest common factor, now in order to find the greatest common factor, it's got to come out of all 3 of them. It's got to be common to all 3. So what number do I know will go into all 3? Well, if I didn't know, I could say 2 because they're all even, but I know that 6 will go into all of those. So I'm going to pull out a 6. 24 divided by 6 is 4. 36 divided by 6 is 6. And 60 divided by 6 is 10. Now, do all 3 of these share a common factor? They do. They're all even numbers. Pull out 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And 10 divided by 2 is 5. Now, do these all share a common factor? Well, no, 3 and 5 are both odd numbers. That's an even number, so I'm done. So my greatest common factor is going to be the product of what I pulled out. 6 times 2 is 12. So it's got to be common to all of them. Now, the last one, I'm going to do a 3 for least common multiple. Let's say I had 16, 32, and 40. Now, if I'm looking for the least common multiple, I can pull out the number that's divisible by at least 2 of them. If I get one for all 3 of them, that's great, but if I get one for just the 2 at the end, that's okay. 16, 32, and 40, I know are all divisible by 4. 16 divided by 4 is 4. 32 divided by 4 is 8. 40 divided by 4 is 10. All of these are even, so I can pull out a 2. 4 divided by 2 is 2. 8 divided by 2 is 4. And 10 divided by 2 is 5. Now, I still have 2 and 4 that are divisible, both even numbers. So if I at least have 2 numbers when I'm finding my least common multiple, I have to pull out of those. So I'm going to pull out a 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And 5 just comes down. It just drops down. Now I have nothing else in common between 1, 2, and 5. I don't even have anything in common between 2 of them. So that means I'm done. So my least common multiple is going to be everything, the big L outside of it. So, and you can do this how you want. Remember the commutative property. I've got 4 times 2 times 2 times 2 times 5. Well, I know 2 times 2 times 2 is 8. And I can do it anyway. And I know that 4 times 5 is 20. So 20 times 8 is 160. So the least common multiple of 16, 32, and 40 is going to be 160. And if I wanted to know the greatest common factor, it's only going to be these 2 because those were the only 2 that was common to everything. So the greatest common factor would be 8. The last thing I'm going to show you, one last thing is on greatest common factor, is if you had 2 numbers like 19 and 35 and you wanted to pull out the greatest common factor. Well, if I look at these 2, they're divisible. They're not divisible by anything except 1. So when 1 is the only thing I can pull out, they are technically called relatively prime. That means they have no other greatest common factor other than 1. All right, thank you.